Ready.
All right, please add these three terms to your list. Statement, conjunction, disjunction, negation are already there, correct? So the first new one is tautology. That's a T-A-U-T-O-L-O-G-Y, tautology. And the definition is right there. A tautology is something that's always true. Like, today is Thursday. Pretty hard to argue with that. I mean, today is Thursday. A contradiction is the opposite. It's always false. Under all circumstances, at all times, it's false. Then you have a contradiction. And the last term isn't really a term, it's a symbol. It's an equal sign that went a little overboard. Equal sign on steroids, I guess. There's 3 lines instead of the normal 2. So it's like equals, but it means logically equivalent, logically the same. Okay? So add those 3 to your notes. We're going to do number 6 together in class. And you'll see the new thing is the logically equivalent symbol. But for right now, if I told you just to make a truth table, I hope everyone in the room would tell me that's not going to be too difficult. Down here. Just P and Q. But it's also kind of nice because that means there's only going to be 4 choices. And what are they?
True, false, true.
True.
True, false.
True, false.
False, true.
False, true.
False, false.
False, false. You got it. Now, just like I did before, I'm going to go ahead and draw this line across here. Just like I did before, I'm going to go get all the negations taken care of. You see any?
Negation P.
Just negation P.
There's negation.
Then negation Q.
No, there isn't.
Oh.
What are those little
Those are the conjunction.
Those really are V's. Those are the disjunction conjunction symbols. So this is a conjunction, this is a disjunction. I just wrote them wrong. I mean, I made them 2 pointed. Okay, negation P would simply be to flip the P column, so go false, false, true, true. False, false, true, true. Everybody with me?
Yeah.
All right, now let's take care of, I don't know, this parenthesis right here. P, and that's an or, isn't it? Disjunction. P or Q. This parenthesis right here. So when I do P or Q, let's see, I'm going to remind myself, or, when you have one of each, it's true. So the true and true is always true. But there's the one of each right there, true. One of each again is true, but 2 falses is false. Are we good? And I just looking ahead here, I'm going to have to do the negation of that column anyway to build this side. So I'm going to just do that next. I'm just going to go ahead and do the negation of P or, come on pencil, or Q. And so I just take this and flip it. So it's going to be false, 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 true. I think I did that right, didn't I? Okay, now let's go work on the other side of this disjunction up here. Let's do the negation P and Q. So negation P column's right there, the Q column's right there. Well, at least they're next to each other. That's kind of nice. And I got to put an and in the middle. So with ands, one of each is false. So this first one right here is false.
False, false, true.
False, true, false. Correct? All right. Well, I think now I can do this whole side, can't I? Put the whole thing together. If I put these 2 columns together, so if I go negation, P or Q, and negation P and Q. So it's putting this column and this column together with an or. So false, false is false. False, false is false. But one of each, since it's or, is true, and one of each is true. So this would be the answer for this side of the logically equivalent symbol. Agreed? Now I go over to this side of the logically equivalent, well, it's negation P, so let's see, that column's right here already. And are they the same? Yeah. So yes, I just proved that all this crap is logically equivalent to negation P. And that's how you do it.
So basically we're just making this truth.
Basically, we're just making, not basically, we are making more truth tables. Good thing they're so much fun. Alright, so in this problem, it says prove that disjunction distributes over conjunction. You know, that's just a bunch of words that means prove this. Prove that this is logically equivalent to this. So since we have three variables, we need a P column. We need a Q column. My pencil's not working very well here. And we need an R column. Everybody with me? And the unfortunate part isn't that. The unfortunate part is now it's going to go down. How far?
40.
Well, yeah, twice as far. Good answer. It goes down 8. So the first one's always the all true thing. Remember how I did the second one?
True, true, false. True, true, false. True, false, true, false.
True, true, false. God, does anybody ever just wish people would leave you alone?
You got some nice ones.
Yeah. It's extremely not normal.
We're going to go diagonal falses. Now I'm going to go diagonal trues.
She's gonna be angry.
You should.
And then I'm going to finish with false, false, false. And if you weren't here yesterday, I said you can copy all this in your notes and you can just copy it out of there. Yeah.
So if we do it in a different order than that, is our answer going to be wrong?
Well, technically no, but yes. It's not wrong, because as long as your answer matches up with the order you put it in, except I don't want to correct that. I want it in the order, that, I want everybody to be in the same order so I can correct it like this millennium. Okay. Alright, so we're doing this. Do I need any negations?
No.
No, that's kind of nice. So let's work on this side over here. So the first thing I'm going to do is the parenthesis, the Q and R. So they're right here, Q and R. Now and, one of each is false. So that first one's true. But the second one, there's the one of each is false. One of each is false. Two trues is true. One of each again is false. One of each again is false. Two falses is false, and they both are. Twice. Are we good? Well, I think I can go ahead now and put the P or that. What, Nicole? So I'm putting this with this, those two together with an or. So true, true is true. True or false is true. Yeah. True or false. True. True again. False or true. 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 False or false. 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 False or false. False. True or false is true. And I end with a false or false, which is false. I think I've got this side done, haven't I? Let's go work on the other side. I need a P or Q. All right, P or Q. They're right next to each other. Well, let's just look at this. If it's or, true, true, that would be true, that would be true. So there's 1, 2, 3, 4 straight trues. Everybody agree?
Yep.
Let me just go fill them in over here. 4 straight trues. Okay. 1, 2, 3, 4. Then there's a false.
Two trees and then false.
And then, yeah, true, true, false. I agree. So that wasn't too bad. Now let's go to this one. The P or R. So now it's this one and this one with an or. So again, it's going to be true, 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 true. I believe there's 1, 2, 3, 4, 5 straight trues. Does that look right? All right. 1, 2, 3, 4, 5 straight trues. Okay, then I got a false, true, false.
And it's going to be perfect.
What's that?
It's going to work.
Okay. Should. So I'm going to hook the whole thing together now. Put that and in the middle. Put the and in the middle of this column and this column. So true, 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 true. I mean, that's pretty easy. Let's see, an and, so that's false, false.
True, false.
And then a true and a false. Okay, so let's see. This is what we came up with on the right side. And the left side was where? Let's see, right here. Are they the same? Yes, they are. So we just proved that those two are logically equivalent. You have both sides of the triple equal sign equal.